Hi everyone, so I'm going to redo the explanation in class of the derivation of our variance formula. So we were looking at how our variance formula here, where remember oh, n is equal to the number of data points, is equal to, what do we have here? This sum right here over n minus just our mean squared. Okay, so that's what we're going to prove, essentially. So what I'm going to do here first, nice and straightforward, is just expand this binomial. So just a minus b squared. So my summation symbol is still here. Then I have x. I'm just going to leave it as x instead of writing xi every single time. X squared minus 2 mu x plus mu squared over n. And the next thing I'm going to do is apply my summation symbol to each of the terms inside of my bracket, and then also separate my one fraction into three separate fractions. So each term written as its own individual fraction. So I've got my sum of x squared over n minus 2 mu the sum of x over n plus the sum of mu squared over n. And what I'm going to do, this term I'm not really going to be able to simplify it too much, but these two I will. So I'm going to number them because I'm going to do the explanation to accompany how I simplify each term. So explanation number one for my middle term here is that I'm going to turn the sum of x into my mean multiplied by my number of data points. Now, how and why does that work? That works because the sum of x is the total value of my data points added together, right? By definition, right? Because it's a sum. So I'm just taking whatever each individual value of x has, and I'm adding them all together for every single term. So for a simple data set, I did this one in class as well. If I had a data set with just 3 points, 15, 20, and 25, that would give me a grand total of 60. And here, even without doing a calculation, transparently, this is our mean, right? Because the 15 and 25 are equally far away from it. One's plus 50, plus 5, one's minus 5. But if I wanted to calculate it, divided by 3 would give me 20, and that would be my mean. So I write mu. Okay? But what happens if I have the reverse? What happens if I don't have my actual 3 data points individually, but I am told what my mean is and how many data points I have? It would just be my mean multiplied by n, right? In this case, and in every case, that's what I'm trying to show, it would just be my mean multiplied by my number of data points, and I would get the same value as if I had all my individual data points to add together, and it would give me the same thing. So that's why in this equation over here, I can replace this numerator with mu times n. So let me do that first. So I'm just going to do an equal sign, copying my first term of my sum of x squared over n. And now this is going to become minus 2 mu, and then my numerator becomes mu times n over n. And I'm aware we can simplify, but for now, I'm going to leave it for the time being. I'm going to do our second explanation. Okay? So our second explanation is that I'm going to turn the the sum of mu squared into n times mu squared. Why does this work? Where does the n just magically pop up? So the reason why this works is, number one, because mu and mu squared is a constant. What the summation really is just, if I were to write it out, the sum of mu squared would just be my mean squared plus my mean squared over and over again. So this would be the first time I do it, plus the second time I do it, plus the third time, plus dot 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 dot, n times, right? And because what I'm really doing is just repeated addition, so it's just mu squared plus mu squared plus mu squared n times, that's the same thing. This is the same as multiplying my mu squared by n, right? Because that's what multiplication is. It's just repeated addition. So that's why I can replace my numerator over there with, so plus n times mu, oh sorry, not just mu, mu squared, my apologies, over n. And now it becomes really straightforward, right? This and this both cancel each other out. This and this cancel each other out. So I'm just left with the sum of x squared over n. And then I'm left with minus 2 is my only coefficient. But then I have mu times mu, which is mu squared. So minus 2 mu squared. Plus, the n's are gone. All I'm left with is mu squared. And now I have two like terms that can be grouped together to give me a simpler equation of my sum of x squared over n minus mu squared. And that is also equal to our variance. Oh, our variance, which is sigma squared. So I hope this example makes more sense now. I hope these two explanations make more sense. Again, they're also written in your OneNote, so not just in this YouTube video, but that is the trust me, bro, derivation so that you actually understand how we get this formula. Because you'll notice the example that we tried to do in class and the example we're going to start with on Monday needs this formula, right? Unless we want to go through the painful process of doing our calculation by hand, which we did at the beginning of Friday's lesson, this will actually save us a bunch of time. So we don't have to fill in 2 extra columns worth of data. Okay? All right. Have a great weekend, and I'll see you on Monday.